Hello, I am back for test 5 corrections, and Lincoln is joining me again because he wants to cuddle. Excuse my hair, it is currently growing out from a pixie cut and it looks really awful, but yeah, not many corrections today, so hopefully this will be a short video. So here's my first mistake. It is a balloon filled to 2.0 liters here in Michigan at 20 degrees Celsius and 752 mmHg is taken to the top of Mount Everest. The pressure at the top of Mount Everest is 253 mmHg and the balloon grows to a size of 5.1 liters. What is the temperature in Celsius at the top of Mount Everest? So this is my math for that problem number 3 here. My math is all correct, but at the end I forgot to enter in the negative sign before my answer, so that was my problem. But to explain the problem anyway, the equation that should have been used was P1 V1 over T1 equals P2 V2 over T2, and then I was able to plug the values in for that and then cross multiply, and at the end, because I did change everything to Kelvin instead of degrees Celsius, I made sure to convert it back to Celsius, and my problem was I forgot to write the negative sign in front of my answer. So instead of 22 degrees Celsius, it should have been negative 22 degrees Celsius. I did forget to explain the sig figs at the end, so I'll do that now. My temperature at the end was 251.496 Kelvin, and I subtracted 273.15 from that, and I got negative 21.65 degrees Celsius. And because the smallest amount of sig figs in the original numbers that were given to me were 2 significant figures, I rounded that up to 22 degrees Celsius, and that's where I forgot to add the negative sign. This is my second mistake. It says order the following from most acidic to least acidic, and basically what you have to do to calculate the pH values of these is you have to type in negative log and then a parentheses in your calculator and then put in the number that's provided. So for example, if I were to do the first one, it would be negative log parentheses 2.3 times 10 to the negative 5, and then close the parentheses, and the answer that you get from that is the pH of that substance. So I did do the math correctly at the time, but I didn't think that I had to write it down because it was a primarily calculator-based question, I guess. And I should have written down my work, but I just recalculated here. So the answers were, for the first one, 4.63, the second, 6.45, the third, 10.2, and the fourth, 2.7. And then it asks us to order them from the most acidic to the least acidic. So here's a random pH scale from Google to make things more interesting, but basically for pH scales, acids are from 0 to 6 point something because around 7 is where you get the most neutral. That's where water is, as you can see here. And then above 7 all the way up to 14 is basic. And it asked us to list them from the most acidic to the most basic. And for whatever reason, I flipped the values in my head. So to me, the highest number would have been the most acidic, but that is incorrect. The lowest number would have been the most acidic, and the higher the number got, it would have been more basic. So I should have ordered them oppositely than how I did. So rather than ordering them from the greatest to least, I should have ordered them from the least to greatest. So in that case, 2.7, which is the fourth selection, should be number 1. 4.63, which is the first selection, should be number 2. 6.45, which is the second selection, it should have been 3. And then 10.2, which was the third selection, should have been 4. And here's my third and final mistake. How many grams would be needed to prepare 121 milliliters of a 0.69 molar, I'm not sure, solution of magnesium hydroxide? So here's my math, it's number 16 right here. I first converted the amount in milliliters to liters, and I used this little pyramid example thing from my tutor. Basically, it helps you to look for a remaining value that you need. So let's say you're looking for moles, then you would do the molarity times liters. And if you're looking for the molarity, then you would do moles over liters. And if you were looking for liters, then you would do moles over molarity. So I used that to help me here. We already have the amount in liters because I converted it, and the amount in molarity, so I multiplied those two together. That's right here, and that gave us our moles, but it wants the answer in grams, so we need to convert that to grams. So we use this conversion factor here, which is the average atomic mass of the substance over 1 mole, and in this case it was MgOH, and I don't know what I did at the time, but I miscalculated it, which was my problem. So correct conversion factor, but I used the wrong number, so I got the wrong answer. Here's a close-up image of my math. I'm not really sure what I did wrong when I miscalculated the grams of MgOH, but what you're supposed to do is take the average atomic mass of Mg, O, and H, and for O and H you would have to multiply those by 2 because there's 2 of each of them, and I'm not sure what I did, but essentially I did it wrong. And the correct amount of grams for MgOH is 58.326, so where I have the number 42.326, it should instead be 58.326. So in that case, when 0.08349, which is the moles that we got originally, is multiplied by 58.326, then we would get the answer of 4.87 grams, which is the actual correct answer. And that is all for today.